In this lesson, we'll look at a complementary assertion to check that two values are not equal. It is an instance method that is called assert not equal. So let's begin by defining a test inequality class. And as always, it's going to inherit from the unit test module's test case class. In here, I'll define an instance method called test inequality, feeding in self. And let's begin with some very simple examples. Once again, our object is self. We've inherited an assertion or method called assert not equal, and it accepts two arguments, and all it's going to validate is that those two objects are not equal to each other. So for example, I can assert that 1 is not equal to 2. I can assert that the Boolean value of true is not equal to the Boolean value of false. I can assert that the string of hello with a capital H is not equal to a string of hello with a lowercase h. And as one more final example, I can assert that a list with the elements 1 and 2 is not equal to a list with the elements 2 and 1. And when I execute this file, we're going to get a passing suite. So as I've mentioned a couple times before, these examples are intentionally simple so that we can understand the syntax. In a real-life codebase, the assertions will really be testing uncertainty. So the goal is to test something that you'll be receiving, such as a return value from a method or a function. So for example, let's say we're defining a program that's going to have a function called copy and add element. I'll define it up here, copy and add element, and it will accept two parameters, a list of values, which I'll call values, and an element. And as the name suggests, my goal here is to take my list, copy it, add or append the element to the end, and then return the copy. So I can implement it like so. I can create a copy of my values list by using list slicing syntax, assign this to a variable called copy. Then I can add on to the end of copy with my append method, adding on whatever element is passed in, and then returning my copy. So let's go ahead and test this method below. So I'll declare another instance method here called test copy and add element, the exact same name as the actual function itself. And here, of course, we'll provide self. So let's simulate an invocation of this function right here. I'll declare a variable called values, which I'll set equal to a list consisting of 1, 2, and 3. And below, I'll invoke my copy and add element function, passing in my list. And let's say I want to add an element to the end of 4. And I'll take the return value of this function and assign it to a variable called result. So obviously the first thing I want to check for is that the return value that I get back from my function is a list of 4 elements, 1, 2, 3, and 4. So for something like that, I can use my assert equal assertion. I can do self.assert equal, and I want to validate that my result or my return value is a list of 1, 2, 3, 4. And when I execute this, we're going to get a passing test suite. However, you might notice that there's actually something we forgot to test, because this function's responsibility is not just adding an element to the end, it's also adding an element to the end of a copy. The intent being that we are not modifying the values list that we are passing in here, right? So what we can do is add another assertion here that validates that my values list has not been changed to 1, 2, 3, 4. And that's going to ensure that we have created a copy. So for example, I can do self assert not equal. I'm going to break this up across several lines. I'm going to assert that my values list, after the invocation of this function, my values list should not be equal to 1, 2, 3, 4, because it should not have been modified. So when I execute this, we're going to get a passing test suite, which is just fine. But imagine that we wrote this code incorrectly. Imagine here that we forgot to make a copy of the list, and we just assigned the copy variable to reference the exact same list as values. In that case, we would pass in a list, we would give it another name, we would append to the exact same list, and then return the original list, which has been mutated. So in this case, our assertion will fail, because it in fact will be equal. Our values list after the invocation of copy and add element will be equal to 1, 2, 3, 4. So we are actually testing here both for the return value as well as the non-mutative nature of the function. So let's fix our original implementation so this problem is avoided. Once again, we can make a copy by iterating over the values list that is passed in. And the last thing I want to show you in this lesson is an optional final argument that you can pass into any assertion from unit test. So I can't always say it's going to be the third argument or the fourth or the second, but it's always going to be the last one to whatever assertion it is that you're using. And what that argument represents is a string that's going to be the error message that's going to be displayed if that assertion fails. So it's only going to show if you have a failing assertion. And you can use this string to provide some clarity or context about what's going on. So for example, here I can add a string like the copy and add element function is mutating the input. Make sure you're creating a copy. So when I execute this file, we are not going to see this on the right-hand side. And again, that is because we have a passing assertion. Unit test has validated that my values list is not equal to 1, 2, 3, 4, so it's not going to display this. However, once again, if I remove this code right here, what we can show you is that this is when we're actually going to see this error message. So if I scroll down below, we have the official one from the unit test module, which tells us 1, 2, 3, 4 is equal to 1, 2, 3, 4, even though it should not be. And here is our own custom message. The copy and add element function is mutating the input, etc. So for somebody who is reading our test suite for the first time, we are providing some more context, some business logic about the specific implementation and what it's supposed to do. And that's all there is to cover in this lesson. We introduced the assert not equal assertion for checking that its two inputs, its two arguments are not equal. And we also talked about the optional final argument that you can pass in to any assertion, not just this one, but anyone in unit test. And it's going to be a string that's going to appear in case the assertion fails. That's all there is to cover in this lesson. So I will see you in the next one.